Hello, everyone, and welcome to today's webinar, Role of Neutralizing Antibodies in Recovery from COVID-19 Infection and Protection Following Vaccination. I'm Susie Valdez of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by DiaSorin. To learn more, visit them at diasorin.com. Now, we encourage you to participate today by submitting any questions you might have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have any trouble seeing or hearing this presentation. This webinar is educational and thus offers free continuing education credits. Please click on the Continuing Education window at the bottom of your screen to obtain those credits. I'd now like to welcome our speaker, Dr. Ashok Ratsan, an advisor, Quality R&D Knowledge Forum Pathkind Labs at the WHO Laboratory Director. Dr. Rattan, welcome. You may now begin your presentation.
Good morning, good afternoon, good evening, wherever you are. It was on 31st December 2019 that WHO was informed regarding an outbreak of pneumonia caused by a novel coronavirus in Wuhan. By 10th January 2020, one full sequence of this RNA virus was available in public domain. By next day, 5 more sequences were available. This made making RT-PCR for this RNA virus easy, and that was one of the first tests to be developed. In India, in January 2020, there was only one lab which could detect coronavirus. But by September 2020, 2,234 labs were accredited and approved for doing RT-PCR by Indian Council of Medical Research. Manufacturers also got many molecular, serology, and antigens tests approved by various regulatory authorities. From Wuhan, the report had already indicated that RT-PCR was less than perfect as far as detection of coronavirus was concerned. And Liu indicated that if you wanted to have better diagnosis, then you need to add serology after 9 days or so. Miller from Boston. So it meant that it was not the gold standard that you were looking for. Miller from Boston then instituted the policy that everybody admitted in their hospital would have RT-PCR and antibodies tested. They found that in the first 9 days, RT-PCR was the most sensitive test for making a diagnosis. But thereafter, antibodies were better for making the diagnosis, while RT-PCR sensitivity fell. And they reported that when used as a complementary test with RT-PCR, after the first 9 days, serology can function as a reliable diagnostic aid, indicating recent or prior infection. So the first few days of infection, RNA or antigen detection is the analyte to test. Thereafter, it is serology which could be useful. Today, our focus will be on humoral immunity and how hosts respond to an infection. Once there is exposure to the antigen, either after infection or vaccination, there is a lag period. Thereafter, the titers rise, and after initial rise, they would decline. It's when the titers are declining that you need a booster dose to jack up the immune response. The two antigens which are of prime importance are the spike protein, which is on the surface, and the nucleocapsid protein, which is inside the virus. Our aim is that in natural infection, the spike protein will bind to ACE2 receptor and enter into the cell and set up infection. We hope to detect neutralizing antibodies which will bind to the spike protein and prevent its union to the ACE2 receptors, and thereby giving protection. It was clear right in the beginning that not everybody produces very high titers. Those who had severe infection and were admitted into ICU had higher titers of antibodies, but those who had non-critical infections or mild infection would have mild response. This might explain why many convalescent plasma trials gave different results if they did not measure the neutralizing antibodies, and some even failed. But it is clear that if the plasma contains high titers of antibodies, then it will be protective. Antibodies, when transfused into animals, provided protection. And animal models, both in Syrian hamsters as well as in African green monkey models, were established, which proved that it was possible to protect against reinfection once antibodies are transfused to them. It was also possible to make human monoclonal antibodies by taking out the B lymphocytes from persons who have recovered and then expanding them. It was a cocktail of these B lymphocytes. B lymphocytes produced monoclonal antibodies, which were injected into the then President Donald Trump, leading to his quick recovery. An experiment was reported by McMahon indicating that when purified antibodies against SARS-CoV-2 were injected into groups of animals, and then they were subsequently challenged with the virus, only the animals which had got 250 milligrams per kg body weight of purified antibodies were fully protected. At the time when they were fully protected, the anti-spike antibodies were 400, anti-RBD antibodies were 100, and neutralizing antibodies were more than 50%. So it emerged that antibodies to spike protein are the key to prevent infection. And you will notice that most of the successful vaccines have focused on spike protein to be the antigen for vaccination. The spike protein is an amino acid. It consists of 1,273 amino acids. It has two broad portions. One is S1. S1 subunit which has the receptor binding domain, and within the receptor binding domain is the receptor binding motif, which binds to the ACE2 receptors. Then there is S2 subunit, which has the fusion peptide. It was also seen that the spike protein is actually a trimeric protein. And the trimeric protein appears to exist, the trimers appear to exist in closed or open form. When it is open, then they have more affinity for the ACE2 receptors. After mapping the neutralizing antibodies, epitopes were mapped on the spike protein, and it was found that there seem to be about 19 different epitopes which can provide protection and neutralization. So it was not only the RBD portion, but other sites on the spike protein, which could, when bound to the antibodies, would lead to neutralization. And it was seen that full protection was better mirrored if you look at the trimeric protein. Trimeric reactive immunoglobulins correlated better with SARS-2 COVID protection. As I mentioned, that the trimeric protein could be in the closed form or in the open form. When one mutation occurred, which opened up one of the trimers, that led to increase in infection. And this mutation was the first mutation noticed in 2020, wherein the mutation was D614G, leading to opening up of one of the arms, and as a consequence, the infection spread. Subsequently, mutations in the RBD have been associated with various immune escape mechanisms and increase in virulence. So in 2020, the mutation which was predominant was B614G, which appeared in February, and by June was the predominant infection found in all over the world. And this year, there has been the Delta variant, which has spread all over the world now. Along with the spread of the variant, there has been also development of monoclonal antibodies. And the monoclonal antibodies could neutralize, a mixture of monoclonal antibodies could neutralize all the variants and have been found to be effective. They could be used They are active against all known variants, and efficacy is 85% in reduction in hospitalization and death. The monoclonal antibodies, or a cocktail of that, could be used both for treatment if given in the first 72 hours of infection, or could be used subcutaneously for prevention of those who are at high risk and are getting exposed. For serological tests, there are various types of serological tests, and not all serological tests are the same. First will depend upon the antigen. the nucleocapsid protein is the most immunogenic, but it resides inside the virus. The spike protein could be S1, S2, or could be trimeric, or we could have RBD, receptor binding domain. Then we could look at total antibodies or IgG, or a mixture of IgG and IgM. And then we could have type of assays, which could be binding antibodies and neutralizing antibodies. It's also very important to choose the right format. The tests are available for lateral flow, but the lateral flow rapid tests are normally not very sensitive and are only qualitative, not quantitative. Recently, attempts to quantitate that has also been made by using fluorescent labels. Then you have neutralizing antibodies, which are mostly ELISA, and you have binding antibodies, which can be chemiluminescence, so they are automated and suitable for high throughput screening. So depending upon the purpose for which you are doing the investigation, you should choose the right serological test. If it is for epidemiology, then nucleocapsid protein, because it is the most immunogenic, would be most suitable. While if you are looking for protection or as surrogate for protection, then spike protein, especially using the trimeric S protein, would be good. The difference between the two is that since nucleocapsid protein resides inside the cell, it would normally indicate infection and would not play a role in protection. On the other hand, binding antibodies can bind to any part of the spike protein. But protective antibodies are those which can protect a person by holding on to the site which leads to infection. By neutralizing them, it is the neutralizing antibodies which indicate the closest you can get to showing protection. Neutralizing antibodies normally are demonstrated by plaque reduction neutralization tests, wherein a monolayer of cells are created and on which the virus is layered, the sample containing the virus is layered. If the virus is present, then virus will cause cytopathogenic effect, which indicates like plaques here, and that would indicate that the virus is present. Neutralization of this plaque formation would indicate that the plasma or the serum contains antibodies which can prevent infection. The problem is that for neutralizing antibodies, you need biosafety level 3 laboratories because you're using live virus which is causing the pandemic, and it takes 3 to 5 days before the results are available. So scientists made pseudovirus since we were interested only in the spike protein. So the gene coding for the spike protein was inserted into harmless virus, and then this could be, and a pseudovirus was created which would provide the same information. This was created initially and reported in China, subsequently in Italy, and this enabled labs with BSL-2 facility to perform the test. But it still took 3 to 5 days. Since we wanted the results the same day, then cell-free, virus-free, genetically engineered RBD linked to a label with ACE2 receptors was used in ELISA, and this would then indicate whether neutralization is present or not. When tested in Singapore as well as in China, it could differentiate between those who had protection and those who had no exposure. This was then given emergency approval by US FDA and also by ICMR and DCGI in India. Many manufacturers could make this test. And when tested, they had equivalent results. When we tested in August 2020, we used, one was the nucleocapsid antibodies and the other one was antibodies against spike protein. And we found that majority of the person tested had low titer antibodies. And so they were not suitable for transfusion. Subsequently, in March, April, there was a big outbreak caused by Delta virus, and many of our staff members also got infected. In fact, in 2020, 11 had got infected, and in 2021, by Delta virus, 12 persons got infected. One person had got infected and recovered from 2020, but 11 new persons got infected. They were also vaccinated. So some of them had taken one dose and some had taken 2 doses and some had not taken any dose. So when we tested them, we found that using S1, S2, 12 have more than 400 arbitrary units per ml. But when we tested with Trimeric, we found that Trimeric was much more sensitive, and 12 of them had more than 2,000 binding antibody units per ml, but many of them had higher titers. WHO has now made standard antibody test available so that the binding unit could be converted, arbitrary units could be converted into binding antibody unit. When we looked at individual responses against S1, S2 and trimeric antibodies, we found that not everybody responded by producing high antibodies. And this was especially in persons who have older age group. Those who had vaccines had medium titer of antibodies. But those who had had vaccination as well as suffered from infection either in 2020 or 2021 by the Delta variant had very high titers of antibodies. Even one dose and infection or infection and one dose produce very high titers. When we added neutralizing antibodies, we found that trimeric antibodies and neutralizing antibodies would go, there was consistency in very high trimeric antibodies and neutralizing antibodies, and so trimeric antibodies could act as surrogate markers for neutralization. But those persons, as I said, if a person has had infection and then taken vaccination or vaccination and then got infected, they had very high titers. Even one dose was enough along with vaccination to produce high antibodies. This was also reported by Kremaker from New York, who found that if we investigated between persons who had pre-existing antibodies and then vaccinated, after one dose, those persons produced much higher titers than those who had not had antibodies. And that remained after second dose also. In fact, those who were already vaccinated or infected and got 2 vaccinations had more side effects than titers. This has then been reported as COVID-19 hybrid immunity. So natural infection itself gives protection from reinfection from the same virus unless a mutant arises, a variant emerges. But infection followed by vaccination will provide much better hybrid immunity. Even in vaccination, initially homologous vaccinations were insisted upon by all regulatory authorities, but sometimes by mistake or sometimes by design. As you know, Sputnik vaccination already has two different human adenoviruses, while Covishield, which is the vaccine used in India, was interchanged by mistake by Covaxin, and they got good results. Same has been reported in Europe with Oxford AstraZeneca followed by Pfizer or with Moderna. So heterologous vaccine seems to be giving good results. But Muller reported that not everybody produces high antibodies. And they found that persons who were elderly had both less IgG antibodies and neutralizing antibodies. From Qatar, the reports came that after the vaccination, there was a decrease in protection against infection. But protection against severe infection or death continued at high level. It was also shown that in transplant patients, if a third dose of the vaccination is given, they have high immune response. From Israel, it has been reported that a third dose to those in whose titers were falling would give them good immunity and protect them. Recently, an ongoing study has been reported, which is the OCTAVE trial, which is observational cohort trials, T cells, antibodies, and vaccine efficacy in SARS-CoV-2 from Scotland. And this has taken patients who are immunocompromised, like having inflammatory arthritis, rheumatoid arthritis, or psoriatic arthritis, ANCA-associated vasculitis, inflammatory bowel syndrome, hepatic disease, end-stage kidney disease, solid cancer, hematological malignancies, and homeopathic stem cell transplant. And they found that all of them had at least 11% less titers than did not produce any titer, and 40% of them have low titers than healthy persons. Anti-spike T-cell response was similar in immunocompromised patients as well as healthy patients. So indicated that the increased susceptibility that they have is because of lack of production of antibodies. Recently, USA CDC has authorized booster doses for certain age groups and certain persons with high risk, and this has been also permitted both for Johnson & Johnson as well as for Moderna. In the past, it was indicated that one dose would give less protection than two doses, and it was encouraged that we should complete the doses as soon as possible. Effect of vaccination was also felt in household transmission. From Scotland, they reported on 1.9 million household members, which indicated 92,000 households with healthcare workers. Of these, those who were vaccinated had less chances their family members have less chances of infection after the first and the second dose than those who were not vaccinated or before the vaccines were available. So risk of infection, hospitalization and death by Delta variant if a person is not vaccinated is 8-fold for infection and 25-fold for hospitalization and 24 for death. So the vaccination provides significant protection against hospitalization and death and some protection against infection. There's also been a trial with variant vaccine so that instead of the original Wuhan strain, the variant, especially the Delta variant, have also been tried, but Alpha, Beta, and Delta have all been tried, and they found that safety was there, and so was immunogenicity. We also feel that a nasal spray vaccination, which would encourage IgA type of antibodies, will protect not only against hospitalization, but also against colonization. And trials are ongoing to try out the nasal spray vaccine. Finally, it is to decide or to understand why some people die and others survive. This study was reported from Yale, which indicated that persons who do not generate neutralizing antibodies by day 14 of infection have more chances of dying, and if by 14th day of infection you have neutralizing antibodies, then chances of survival are high. So it was the 14th day which appeared critical of infection. If by 14th day you have neutralizing antibodies, chances of survival are high. And if by 14th day antibodies are not developed, then it might end fatally. Recently, from Peru, they have reported that nanobodies have been found in llamas, and those have high affinity to neutralize SARS-CoV-2, and maybe they will soon come into therapeutic use. So there's a lot of things available, but deviation from COVID-appropriate behavior is currently the biggest variant of concern, and I hope that while we strengthen our diagnostic ability as well as our treatment facilities, we should continue to practice COVID-appropriate behavior. That's all the presentation I had.
Thank you so much, Dr. Rattan, for that informative presentation. And we will now start the live Q&A portion of the webinar. If you have any questions you want to ask, please do so now. Just click on that Ask a Question box located on the far left of your screen, and we'll answer as many questions as we have time for. So it looks like we already have some great questions coming in. Our first question, in your country, sir, how is the vaccine coverage? Is the third booster dose already implemented?
In India, recently we celebrated 1 billion doses of vaccines. We have a population of 1.3 billion. 65% of that population is eligible for vaccination at this point in time, and it appears that 20% have been fully vaccinated, and many more, about 71.71 billion, have received at least one dose. At this moment, booster dose has not been allowed or permitted in India.
Thank you so much. Now, our next question coming in, do you have some evidence about the performance of TrimericS IgG assay with the Delta variant?
Yes, I showed you the data that I had with our own staff members who contacted the infection in April and May of this year. They had very high titers after they've recovered. Many of them had been vaccinated. Some of them were not vaccinated, but they produce high titer of antibodies. And once they have high titers of trimeric antibodies, they also have high titers of neutralizing antibodies. So neutralizing antibodies is a manual process by doing ELISA, while trimeric is an automated chemiluminescence process, which is faster and better and more hands-off. So it is suitable for high throughput, and high titers of antibodies were found in those persons who had suffered from Delta.
Thank you so much, Dr. Rattan. And I want to thank our audience for these great questions. We have one more question coming in. Dr. Rattan, literature is reporting that there are certain groups of immunocompromised patients, for example, HIV and patients, that do not differ in their serological response to vaccination from the healthy controls. Would it make more sense to first measure their serological response after vaccination prior to giving them an additional vaccine dose? What are your thoughts about that?
Unfortunately, in our group, we have not had anybody who has HIV positive. So I don't have any data on HIV. But on the other hand, as I've indicated, that those who had infection in 2020 and got one dose had high titers of antibodies. So on one hand, we say that there is shortage of vaccination. On the other hand, we are giving a second dose to those who don't require it. So I think it will be judicious that those who give history of getting infected and then having one vaccination dose or one dose and then infection should have their antibodies tested before the second dose is given, because as Kramariker also indicated, there are more side effects if you already have high antibodies and then you take the second dose of the vaccination.
Dr. Rattan, thank you. Oh, go ahead.
There's also that those who are elderly or those who have any immunocompromised status should get their antibodies tested, because not everybody is responding. And it is clear that it is antibodies which are protecting against hospitalization and death. And that is why monoclonal antibodies are also available for both for prevention as well as therapy. So for personal health, those who are immunocompromised or who are elderly should get their antibodies tested.
Dr. Rattan, I want to thank you for your presentation today. Would you like to provide any closing remarks to our audience before they go?
I think I would like to repeat once again that the virus seems to be very smart, and it is the COVID-appropriate behavior, that means wearing the mask when in public, keeping distance, not congregating indoors, and not having too many meetings, face-to-face meetings. We should continue to do that while we hope that the vaccine will hold and the virus will no longer mutate and become more immunogenic, more transmissible, and will have immune escape mechanism.
Dr. Rattan, I want to thank you again for your time and for your research. We also want to thank LabRoots and our sponsor, DiaSorin, for underwriting today's educational webcast. And before we go, I want to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period will be addressed by our speaker via the contact information you provided at the time of registration. And this webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Stay safe. Bye-bye.
Thank you.